Hey guys, welcome back to another RESK maths tutorial, and in this tutorial I want to show you guys a trick to always get inequalities correct no matter what. So inequalities sometimes have a reputation of being a bit like guesswork, but they can actually sometimes you know exactly what to do, and other times it's a bit confusing. So let me give you guys an example and then show you guys the method which I'm talking about, which is going to help you never make mistakes on inequalities. Let's say we have a basic inequality such as y is greater than x plus 1. Let's just say that. So the usual method, at least for me, is just to first of all draw the graph. And then, so if it's going to be x plus 1, it's just going to be something like this. And from here, all we have to do is, since y is greater than x, we usually just assume that it's on the top half like this. And I know this line should be dotted, but that's fine. I think I'll just change that. Okay. So usually, since y is greater than x, we just assume this, but this is a bit tricky. Like, it works when it's linear, works if it's just a constant over quantity. So if x is greater than or equal to 1, it's going to work for that as well. But just sort of guessing where the inequality is true, that doesn't work once you get to slightly more complicated scenarios. So even on a quadratic inequality, let's say we have something like x squared plus 7x plus 10 is less than or equal to 0. So actually, let's do greater than, since that's a bit better for this example. Okay, so we know this is going to look something like this. Specifically, the curve of this is going to have roots at x equals minus... Oh, I just realized I drew it wrong. It's going to look like this, actually. So yeah, specifically, this will have roots at minus 5 and minus 2. Those aren't too important, but the important thing is that we find the region which satisfies this inequality. And where this is greater than or equal to 0 is also just where any part of this is not below the x-axis. So it's going to be everything past the line, so everything past this root, like so, and everything like this. So that's fine. But what if you want to do something like x squared plus y squared is greater than or equal to 1? So some of you might know this is the equation of a circle, and specifically of radius 1. But from this, it's clear that if it's going to be greater than this, then the radius has to be greater than or equal to 1. So it's everything outside the circle. But how would you do that if you had no idea this was a circle equation? Well, here's my method. So first of all, we split the graph into, let's call them distinct regions. And a region is just an area bounded by the curve's line. Bounded by a line. By lines, okay. So in this case, we have two areas. We have area 1 and we have area 2, like so. Okay. And sometimes if you want, you can also include specifically, like you can look at these. So you can include the 1, 2, 3, 4, 5, 6, 7, 8. But I believe that's too complicated if you include the axes as well. So only include the axes if it's one of your inequalities, like if it was in a system. For now, we can just do area 1 and area 2. Now what you want to do is just pick a point from area 1 and area 2. So in this case, from area 1, the point is going to be the origin, or 0, 0. And all we have to do is put these xy coordinates into this equation and check if it's true. So is 0 plus 0 greater than or equal to 1? That's not true, so it fails the inequality there. And our representative point for 2, 2, it can be anything, but what we can do is I'll just pick like 3, 2, since I know that's not in this circle. And we'll just check. So is 9 plus 4, 13, that is greater than 1. So therefore, area 2 or region 2 is valid. Now, this is fine. This is fine, like, it works well, but I think to make this even better is you can realize that you can also bring infinity into this, and that just makes calculations a lot faster. I know it's counterintuitive, but let's say we know infinity somewhere over here, that is not going to be included, so that could be our candidate point 2. So let's just say point 2 is infinity. We know infinity squared plus infinity squared is obviously greater than 1, so that's a tick. And the reason this is just so good is because when you're working with infinity, you're no longer working with specific values, but more just you're dealing with magnitude. And like, it's pretty clear that 2 times infinity squared is going to be much bigger than 1. So infinity, as long as there's no sort of overlaps or dividing by infinity, then it makes the calculations much easier. So there's my method. It's simply just split group into regions, then test each region, and that tells you which ones are true. And a bonus tip is to try to use infinity when possible. Anyways, thanks for watching, guys. That was just a quick overview. I just wanted to share this little tip I learned when dealing with complex inequalities. Thanks for watching, and I'll see you guys in a future tutorial. Bye.